what we're having a look at now is the 2015 application task questions. So we're going to start with question 2. So it talks about baseball and then shows the height of the ball. So we're going from 0 to 115. So we're looking at the position of the ball above the height of the ground over 115 meters. So we can model it with this. So that's what we're going to do first. This is a bit of a worry. Why do they call it H against D? Shouldn't it be H against X? Anyhow, so we'll define this thing, and then we'll go on and we'll answer the rest of the questions. So we'll define this. Where's Kaz? New thing. So define H of X equals negative 1 over 100. Negative 1 over 100 x squared. Negative 1 over 100 x squared plus 6 over 5 x plus 7 over 10. We'll just check that matches up with what we've got there. Yeah, good. And we need to define our domain. Given that it goes from 0 less than or equal to x, which is less than or equal to 115. So our square brackets less than or equal to 115. So we want to sketch that graph first. So we know we're going to go between 0 and 115. So we'll modify h of 0. Just set our window. H of 115. Okay, so we know we're at about 70 centimeters, and then we end up at some height. So let's have a look at this. So menu window. Oh no, we don't want that. We want a graph. H of X. See what's going on there. We will set our window zoom, window settings. Let's set our X minimum to -2, our X maximum to 120, our Y minimum to -2, and our Y maximum to say 50. I can't imagine hitting a ball higher than 50 meters. So there we go. That's a nice curve there for us. Okay, so that shows the path of the ball. All right, so that's what our sketch has. Now we want to show labeling intercepts, endpoints or stationary points using coordinate points. So our endpoints, so we'll have, so for our h of 0, we've got 7 over 10. So we'll have 0 and 7 over 10 here as coordinates. We will then have 115, and 129 over 20. So we'll have 115, 129 over 20 as a second set of coordinates. We need to find out our maximum. Let's see if the graph lets us find a maximum with exact figures. No, that's not what we want, but it gives us an idea. It tells us it happens at 60. So what we can do now is we can go back to here, h of 60, and tell us that it is 367 over 10. So that's what we put down. So we put down 60, 367 over 10. Mind you, 36.7 is exact. Okay, so that's a done. Now, what is the maximum height reached by the ball? So it's one mark. You just write down an answer. 167 over 10. 336.7 meters high. Yeah, that's it. What is the horizontal distance as the ball first reached 30 meters? Okay, so we want to find where it reaches 30 meters. So let's go back. We're going to say solve h of x equals 30 for x, and it tells us it happens at these two values, and that's what it is. It's this thing here. We can also, so you'd be writing that down. We can also, we can say, let's graph 30 and look for an intersection point. Analyze graph, intersection, so it happens 31.4, and that's what we end up with there. So we know that's, wrong way. We know that's about the same thing, so that's where it ends up happening. Okay, next question. Remember to use exact values. Will you be writing that down? Find the average rate of change from 5 to 70. Okay, so now with this we're going to say, so looking at, so over 70, say from 5, so that graph. So from x equals 5 here to about x equals 70 somewhere here. That's what we're looking at. We're looking for the average rate of change between those 2 points there. Okay, so for that, what we'll do is we'll say h of 70 minus h of 5. I'm going to say all of that divided by 65. We end up with 9 over 20. Now let's just check that again. We'll say h, so say h of 70 h of 70 minus h of 5 divided by 70 minus 5. There we are. So y2 minus y1, x2 minus x1. End up with 9 over 20. Find h dash of x. So derivative, menu, calculus, derivative, x, h of x. That's what our derivative is. Don't look right. 6 over 5. No, that's fine. That's what we end up with. That's our derivative. Now we want to find the equation, to the tangent of the curve at that point. So to find the equation to the tangent of the curve, we need to find, so we want to write that in terms of y equals mx plus c. So that's what we want to do. So now we've got our y coordinate and we've got our x coordinate. So we've got our x coordinate here as 40. Our y coordinate is that. We need to find the gradient at 40. So we're going to say menu, derivative, that's very calculus, derivative point x, our value is 40 of h of x, so 2 over 5. So our value for m, that's our value of m, 2 over 5. So we'll say y equals mx plus c. Now for y, we choose our y coordinate, which is 32.7. So 32.7, Our m is 2 over 5. Our x value is 40. So say times 40. And we're going to solve for c. We don't know what c is, so we'll put this all into the brackets. Solve that for c. c equals 16.7. Show full working out. So what we'll do, we'll write down, that's our value, we'll write down y equals mx plus c like I did. Y equals, at x equals this, the gradient is this, then y equals this, x equals this, substitute onto y equals mx plus c, and we solve for c, and we end up with 16.7. So we'll say y equals 2 over 5x plus 16.7. That's what we'd write. No, not point, sorry. 16.7. So we'd write that. Okay, so that's a tangent. Now, do we want a normal? Show using interval notation the values to x, which is gradient is positive. So look at where the gradient is positive, where the function is increasing. So where is the thing positive? So we will solve. So we're going to define the gradient. So we're going to say h dash x and define h dash of x equals the derivative x of h of x. Done. Now say solve h dash of x is greater than 0 for x and have between 0 and 60. That's where it's positive. So once again, 1 mark, so we just be writing down that answer. And I think that's it for that question. Oops. Yep, that's it for that question. That's all we need to do. Well, another video for another question.